Dive in. It really does seem like two totally different worlds, doesn't it? But that's the big question we're tackling. How are the smallest things we can imagine connected to the biggest things we know exist? The answer? Well, it's pretty amazing, and it shows a hidden pattern that runs through, well, everything. So, let's start our journey at the very, very bottom. We're talking about the fundamental building blocks that make up everything around us and, of course, everything inside us. This is our invisible foundation. Now, at a quick glance, these might just look like a couple of diagrams from a textbook, right? But take a closer look. On the left, you've got the cells that make up our bodies, and on the right, that's what happens when particles dissolve in water. One is alive, the other isn't. But here's the secret they both share. Everything, and I mean everything, is built from tiny, invisible pieces. So what in the world is a cell, really? You know, the simplest way to think about it is that it's the smallest possible thing that can actually be called alive. Every single living organism, from a tiny ant to you and me, is made up of these little guys. They're basically the microscopic engines that power all of life.
And you know what's really cool? These cells are total team players. They don't just drift around doing their own thing. Oh no, they specialize, they organize, they form these incredibly complex systems. I mean, just look at our blood. You've got trillions of red cells that are like a delivery service for oxygen, and then you've got white cells acting like a security team, fighting off any intruders. It's a whole society of tiny workers all cooperating just to keep you going.
Okay, so we've got it. Life is built from cells. But that brings up the next big question. How does life keep going? How does it make more of itself? So let's scale up a bit, from just one cell to the amazing process of creating a brand new organism.
This, right here, is the biggest challenge for every living thing out there. It's just not enough to exist. You've got to make copies of yourself. And over billions of years, life has come up with some truly brilliant ways to get that job done. For a lot of plants, the whole process really comes down to these two essential steps. First up is pollination. That's all about getting the genetic material to the right spot. Then comes fertilization. That's the magic moment, really. It's the fusion of sperm and egg that creates a zygote, which is the very first cell of a whole new plant.
But here's the thing. Making a new plant isn't a one-size-fits-all deal. Life has kind of two main strategies. On one side, you've got asexual reproduction. Think of it like a biological copy machine. It's super fast, super efficient. But on the other side, you have sexual reproduction, which is all about shuffling the genetic deck. It creates variety, and that variety is what helps a species adapt and survive when things get tough.
Okay, so we've seen how life organizes itself from the ground up. But what powers it all? And for that matter, what powers the world we've built? Well, the answer is in this invisible force, a hidden flow of energy that we've figured out how to use.
I'm talking about electrical energy. At its core, it's just the movement of charge. It's a fundamental force of nature that we've learned to control, from a tiny little spark all the way up to the massive generators that light up our cities. It's the invisible river that our entire modern world flows on.
Now, to control this flow, we use circuits, and there are basically two main designs. The first one is a series circuit. You can think of this like a one-lane road. All the electricity has to follow that single path. The second is a parallel circuit, which is way more like a highway with a bunch of lanes, giving the current lots of different routes it can take.
So why should you care about this? Well, just look around your room. You remember those old holiday lights where if one single bulb burned out, the whole string went dark? Yep, that was a series circuit. Your house, on the other hand, is wired in parallel. That's why if your TV blows a fuse, the lights in your kitchen stay on. A problem in one path doesn't take down the entire system.
Pretty smart, huh?
All right, get ready. It's time for our grand finale, our biggest leap yet. We've gone from microscopic cells to the circuits in our walls. Now, let's zoom all the way out and take a look at our place in the universe. Welcome to our cosmic neighborhood.
Just look at this table. It really puts the sheer scale of our solar system into perspective. I mean, check out Jupiter. It's so big you could fit over 1,300 Earths inside of it. And then there's the time scale. A year on Mercury is just 88 of our days, but a year on Neptune? A mind-boggling 165 Earth years. The numbers are just staggering.
And you know, when faced with this unbelievable scale, what did we do? We reached for it. And what's truly wild is how fast we went from just looking up at the stars to actually going there. In 1957, we launched Sputnik, the very first satellite. And just 12 years after that, we were walking on the moon. It was an absolute sprint of human ingenuity. So, we've done it. We've journeyed from the micro to the macro. We started with a single cell, and we ended up in deep space. Now it's time to bring it all home and answer that first question. What's the connection?
And here it is. The connection is perfectly shown by that little device you carry around everywhere, your phone. GPS is this huge network of satellites, a massive piece of cosmic engineering. But what does it actually do? It beams down a tiny signal, a little piece of data, that helps you find your way to the grocery store. And that's the link. Our biggest, grandest achievements in science often serve our smallest, most personal needs.
And really, that's the big takeaway from all of this. Science isn't just a bunch of separate subjects in different boxes, biology here, physics there. No, it's a single, beautiful web of interconnected ideas. It's the story of how everything, from a living cell to an entire galaxy, is actually part of the same grand system.
Think about it. The same fundamental rules that organize a cell and push electricity through a wire are the same rules that guide the planets in their orbits and our satellites in space. It is all one incredible connected system. So the real question isn't just what we'll discover next, but how that next discovery, no matter how big or small, is going to connect back and change our lives right here on Earth.